Hey there. So, in this lesson, we'll be talking about statistical indices, or just indexes. So what are they? They are numbers used to quantify trends. Most indexes use a base of 100 and make figures, well, they use that to make figures easy with. Indexes are used on reports on numerous variables, including consumer prices, stock prices, customer satisfaction, and human development. Now, if we do make a graph, we sometimes we work with weird numbers like hundreds of thousands, if not millions. But what they do is they change those numbers in terms of 100 to make things easier for you to read and easier to work with. So that's what it is. It's just a transformed number into a base of 100, and they just work from there. A statistical index, what is it? It is a weighted mean used to show the change over time. The change is measured with respect to the base period. And again, they often make the base 100. And the best way to learn, as always, is to do examples. So, let's read the first example. The primary index for the Toronto Exchange is known as a TSX Composite Index. The graph is shown as a TSX Composite Index from January 1st, 2000 to August 15, 2008. The top portion of the graph shows the value of the index. The bottom portion shows the volume of sales in billions per dollars per month. So we're more interested in the top part here because we'll be using these numbers. So it says here, by what factor did the index grow from January? And I wrote down the index here so it's easier for you guys to work with, to September 1st, 2000. Again, I wrote down the index. Now, what is a factor? A factor is just a number divided by a number that tells you how many times something is or how many times something is small. It's a multiplication factor. So let me just get my pencil tool and write it up here. So the factor, in short, is just the well, it's going from here. This is the I would say this is the I would say this is the old. So this is the old. That's the new. So it's going from here to here, right? So you want to put the new over old, so it's growing in a sense. So it's basically 100, 11,388.82 divided by 8413.42. And that's all it really is. It's one number over the other and tells you how many times bigger or how many times smaller a number is. So in this case, this is going to be 1.35 times bigger. That's all it is. It's basically 1.35 times bigger. Okay, so next problem. Oh, it's continued on. And again, to make this simpler, I wrote down the numbers here. By what factor did it fall from September 1st, 2000 to October 9th, 2000? Again, I wrote down the numbers here. And these are indices, I believe, index values. They don't actually represent the money. They're just numbers that represents the money, but not the actual money itself. They're just numbers. That's what indexes are. They're just numbers that represent something. So, factor. What is the factor? So it goes from here to here, and it's actually falling. So you will get, again, this is the new, and that's the old. So the new, we put that on top, which is 5695.33. And the old is 11388.82. And that is going to give us a small number, 0.5. So it actually falls by 0.5, by a factor of 0.5. So if you multiply this by the second number, it will give you this number. So it says here, what is the percent change index between August 15th, 2007, and again, I wrote down the numbers here for you, and 2000 and August 15, 2008, and the other number here. This is different. This is the percent change, and we're supposed to use the percent change formula. We learned that in the previous units. So, percent change. And this is the old, that is the new, and it is always the new minus old, which is 13,096.70 minus the old 13,048.76 divided by the old 13,048.76, and we have to multiply that by 100% because we're working in percentages, and we should get a value of, let's take a look here, it is 0.367% change, or you can just say 0.37 percent change. Okay, so we have another one. Seems like the same problem. And I wrote down the numbers here for you so you can see. Again, all these numbers are taken from this graph, from this graph right here. Okay, what is the percent change from the index from October 1st, 2008 to October 10, 2008? That's a very short period of time. So here again, we can use a formula. Percent change equals, and then bracket. So this is the old, that there is the new. So we have here 7, 1, 4. Oh, whoop, that's wrong place. It should be a new minus old. So it would be 9065.16 minus the old 71451. Dot there, put that there. Divide that by 71451 times by 100%, because percentage is always by 100 in 100%. And we get a number of, hold on here. Oh, wait, something looks fishy here. I see it. Okay, my mistake. So this number here, 7414, that's not the correct number. Let me just erase that from here. And let me put in the correct number. So the correct number for here, I believe it is, I'm gonna write it in. Oh, let me just get the pencil tool. The correct number should be 11714.51. That's a wrong number there. I'm going to change that in the notes. I'm going to put the correct number here, 11714.51 divided by 11714.51 multiplied by 100, and you should get negative 22.62%. So the negative represents a fall. So it's basically falling from, it's basically not going down, but it's a decrease. That's what it represents. Okay, I'm gonna make that change. Okay, let's continue on. So let's look at the last part here. Describe the trend in sales over most of the period. Well, in this case, if you look here on the bottom part, it looks like it generally increases. I will say it increases, it basically increases from, well, from 2000 all the way to 2008, and there's a spike, right here. So this is 2003. So this is the first half of 2003, and this is the second half of 2003. So it looks like the second half of 2003. So you can say second half of 2003. Okay, so let's move on to the next problem. Now things get a little bit more trickier here because this is somewhat weighted. Let's read the problem. Example 2, Farm Product Price Index. The Farm Product Price Index, which is FPPI, follows the pricing farmers gives their product. So in April 2008, the FPP for 2000 so not 2000 1997 is 100. So this is the base. You just converted that number into a base, and it stood at 119.7. So that's basically a score in a sense. So for 2008, it's this value for 2008, but 2007 was 100. So they use that as a base. The sub-index weighting for 2008 crops were 45.4%. The sub-index weighting for 2008 livestock were 54.6%. If you add those two numbers together, you get 100%. Each sub-index is broken down into basic indices representing, for example, grain, fruit, cattle, so on and so forth. Okay, that's good. Explain what is meant by 1997 equals 100 and how it relates to 2008. Okay, so what this means here is that there's a jump between 100 to 100, 119.7. So what does it jump by? Well, if you think about it, it jumps by a factor of well, if you do the factor part, so if you factor it, it'll be 119 um 1197. Oops, let's go back there. Over 100, because that's 100, and it's essentially 1.197. So that's a factor of 1.97 that it jumps by. It represents the increase in price of 19.7% in a sense, because if you think about it, that's a factor, but if you think about it, in reality, it's really 1 plus 0.197, and this is that there's a percentage wise. But if you don't have to take my word for it, you can actually do a calculation. Let's do a percent change calculation. So percent change, and we're going to use this is the that there is the new and that there is the old. And if you do the calculation, which is 119.7 minus 100 divided by 100 times 100, and you will find that the value is going to be 19.7%, which is sort of the same thing as that there. So you can see that percent change right there. Okay, next problem. It says here that in 2008, the crop index had a value of 144.2, and a livestock index had a value of 94. Show how these values are used to determine the value of the PPI. Okay, so to solve that problem, you basically it's the same thing. It's like a weighted problem. So you're gonna get new values based on what the increases are. So let's do FPPI. And on the top here, we're going to put down 1, 4. Use how these values are determined the value of people. Okay, so 114.2 there. Oops. And we are going to multiply it by 45.4%. Because we're using weighted values. And over here, it's going to be 94.4, or so not 94, it's 99.4, 99.4, and we multiply by its weighted value, and I believe if you look up here, its weighted value is 54.6, 54.6%, and on the bottom here, You add these two together, that's 100%. And we should get a value of 119.7. Okay, that was just a weighted value problem. So these are the weighted values here, and you just apply them to the number. So the number was given here. Oh, the number, they give you the number here. The number here, and you apply the weighted values to those. Okay, it's a crop. Okay, this is an interesting one because there's a crop, there's an increase here. So this is a little bit more trickier. You have to recalculate the FPPI, except you have to take into account the increase and the decrease here. So FPPI, and it's the same formula, which is 144.2. Again, if you look up here, it was 114.2. The only difference is that there was a 1% increase. So how do you increase this by 1%? So I want to increase this by 1%. Well, I know it's going to be 1.01 there. If you multiply these together, that's an increase of 1%. Or in short, it's basically 1 plus 0.01. This is 1%. And so if you add a 1 to it, it shows an increase by 1%. So that's that. And then you put the weighted value. The weighted value, again, if you look up here, is 45.4%. 45.4%. And that's there. And you do the next one, which is 99.4. 99.4. And it says here it decreases by that amount. Well, I want to find what the actual number is. So in short, a decrease is basically 1 minus 0.5, which is essentially essentially it's 99.5, I believe. 99.5. Or not 99.5, it's 0.995. So if you multiply this here, this number here, by 0.995, multiply these two numbers, then this number will get smaller by 0.5%. It's getting smaller by 0.5%. And then we add our weighted value again, which is 54.6%. There we go. The whole thing divided by 100, because this plus this gives you 100%. And we get a value of 120.1. Now I want to go back over here and show you that it's a decrease by 0.5%. So what I could do is I can get 99.4, and I can multiply it by 0.05, and I can find the value of that, which is 99.0, okay, 99.4, hold on, 99.4 times 0.05. It tells me that number is essentially 4.97, right? So basically, you minus that number because it's decreasing, right? So you get 99.4 minus 4.97, and let me just minus it here. 0.4, and you have 94.43. This will equal 94.43. So these two numbers here, it will if you multiply, if you do this, you get 94.3. But if this is here shortcuts. This here is a bit of a shortcut. This part here. So when you subtract it by this, 1 minus that, it gives you this number, which will decrease this number. Because you know it's decreasing. It says decrease. Right? If it's increasing, then you add a 1 to it. If it's decreasing, you subtract 1. 1 subtract. So if it's increasing, you do it like this. If you see an increase, the percentage. But if you see it's decreasing, it's 1 minus the number here. And it gives you 99. You put the number in and you got that value right there. Okay, I hope that's I know that's a little bit unclear, but again, I'm gonna say it again. If you see the word increasing by 1%, then basically you're multiplying it by 1 plus the percentage here. If you're seeing a decrease, essentially you're doing 1 minus the percentage. In that case, it'll be 0.05%. And then you multiply it. So I got 0.995, and then I multiplied it, and I multiplied the weights, and then I get the value. Okay, that's about it. So good luck with the homework, and yeah.